Good day everyone, you are welcome to today's tutorial. In today's tutorial, we want to consider flood risk assessment based on building density, and we have a practical question here we want to use to address it. And the task is this: the National Emergency Management Agency found that an area demarcated as vulnerable will experience devastating flood in the coming months. In preparation for the flood, the agency wants to carry out flood risk assessment based on building density in the area into no risk, area with no risk, area with buildings ranging from 0 to 270 per square kilometer is classified as no risk. The moderate risk, 271 to 547 per square kilometer. Then area of high risk will be area with buildings ranging from 548 to 820 buildings per square kilometer, and the very high risk is greater than 820 buildings per square kilometer. So the task is, as a GIS analyst, produce the flood risk map based on building density and classify as stated by the agency. Now we have to take note of two things here. Of course, there are many variables to consider in flood risk assessment. However, in this very task, one variable is given, which is building density. So we are going to concentrate on that. And the classification is already given as follows here. The data to use is also provided. So let's check it out. Here, I have it in this folder, flood risk assessments. So open the folder. This is the data given to us to use for the task. Now, what to do now? Open ArcMap. Let's open ArcMap and bring in those data. So to do that, click here and navigate to that very folder. This is it, flood risk assessments. Then we have these two data given, building and boundary. Click add. So we have this data here, the buildings and the boundary. So this area is considered as vulnerable, and we have a whole lot of buildings within this area demarcated. So the task is to carry out building density analysis to be able to identify areas that have high risk of flood. So now we have to take note of some things here. Here, if you look at the status bar, you see that it's in decimal degree. As I'm moving my cursor, you can see it in decimal degree. So if you come to this layer and verify the coordinate system of this layer, right click and come to properties. So come under source, you see that it is geographic coordinate system. So the data given is in geographic coordinate system, so we have to project it. So to do that, come to spatial analyst tool, come to data management tools, and come to projection and transformations. Then see project, double click it, then input the first layer, which is buildings, and you can see the original coordinate system. Then click here to navigate to the folder where you want to save it. So let's still save it in the flood risk assessment folder. So let's call it now building 2. So then click on save. Here, output coordinate system, click here. So let's choose the coordinate system, come to projected coordinate system here, come to UTM, come to WGS 1984, come to Northern Hemisphere, and come to the place where this data belongs to is UTM zone 32. Click on that and click on OK. So it has been added. Then click on OK. So the projection is going on. So it is done. Then we also do for the second layer, double click here, click here and bring the boundary. We are projecting the boundary as well. Click here. So let's name this boundary 2. So click save. Then click here. So we are still choosing the same coordinate system. Click on OK, then click OK. So the projection is ongoing, so it's done as well. Now that we have projected the two data given to us, so you can now open a new project or continue with this. So let's open a new project now. Yes, let's bring in the projected data. Click here. So navigate to that same folder, which is this, that is boundary 2 and building 2. They are the one we projected just now. Click on add. So immediately we add, we can see. Then let's verify. Right click, come to properties, then come under source. You can see it now is projected coordinate system. So we are sure of the coordinate system now. So now the question is that we should carry out building density. This is the keyword, building density. So to do that, click on Arc Toolbox, come to Spatial Analyst tool, come to density, then point density, double click it, then here click here. Our input is the building, then population field, leave it as none. Then output raster, click here and navigate to your folder where you want to save it here and name it building density. So click save. Here neighborhood, click here, let's leave it at circle. Then units, let's leave it at map units. Scroll down here. So the area units, remember that the question says that the classification should be in square kilometer. So in that case, here we leave it at square kilometers. So if the question says otherwise, you choose the unit specified. So we are leaving it at square kilometer. Then the question also says the area demarcated, which means the area under consideration is within this boundary. So we have to set the environment such that the analysis will be within the boundary. To do that, come to environment, come to processing extent, the extent here, click here and choose boundary. Then scroll down, come to raster analysis, scroll down again, come to mask, click on this drop down and choose the boundary. So click OK and click OK. So the point density process is going on. In few seconds to minutes to be done. Yes, it's done. Now for us to view it, click here. Let's change this boundary to hollow and click OK. So uncheck the building points. So this is the building density. However, to appreciate it, you can come to this building density layer, right click, come to properties, then come to symbology and change the symbol to any color of your choice, the color that you enhance it. Then you can format the label, number of decimal places, let's say 2 or even 1. Click OK, click OK. Yes, this is the building density map. Now the question says we should classify based on this number of building per square kilometer into no risk, moderate risk, high risk and very high risk. So that's what we want to do now. To do that, you come to Spatial Analyst tool, come to Reclass, click here, then you see Reclassify, double click Reclassify. Then our input here will be the building density we just created. Then click on Classify. Now we are to classify into 4 classes. Click here and choose 4. Then come back here and look at the figure 0 to 270. Then come back here, type 270. Then the second one is 547. So here type 547. Yes, and the next one is 820. 820. Why the last one is greater than 820. So we are done now. Then click on OK. Now here, click here to navigate to our folder where we want to save it. So let's just call this reclass, that is reclassify building density. So click on save, and remember that 0 to 270, according to what we are given here, if you recall, 0 to 270 is no risk. It's no risk. So come back here. So 0 to 270 is no risk and it's 1. This 270 to 547 is 2. So remember this new value. So click on OK. So the reclassification is going on. Yes, it's done. So let's uncheck this. So this is the reclassify building density map. Now right click and go to properties. So come under symbology. So the label 1 is no risk. And the last one is very high risk. Yes, click on OK. Yes, you can see our map now. So you can rename this one as flood risk map. Yes, flood risk map. Then we can take it to layout. Take it to layout. Is add your map elements. Let's add the grid, new grid, next, label only, okay, next, finish. So let's just apply to see what we've done. Apply. So those gap is too much, so go to properties again, come to interval. So let's say 3. Then come to label. Let's choose 12 and make it bold, left or right. Click OK. Apply to see. Yes, it's good. You can also change the frame and choose. Click on OK. So we can add other elements to our map. Zoom to layer. Okay. So let's add neat line now. Right click, come to properties, fill color, no color, increase it to 5, click OK. Yes, so we can add other elements now, like our legend. Next, edit this. Next, if you want background color, click next, finish. So this is our legend. Then we can add our, come to insert, add the scale bar. You can choose any one of your choice, click OK, then bring it down and edit it. You can add all other elements you want to put on the map. You can calculate the area of each of these flood risk level. So to do that, right click here, open the attribute table. So click here, map options, and add field. So let's call it area, and type double, then click OK. Then to know, right click here, come to properties, then come to source. This is the cell size of the map, so let's copy it, 29.07. Copy, cancel. So come here, right click, fit calculator, yes. So area is equal to count multiplied by, right click, paste the cell size, times, right click, paste the cell size, close bracket, divided by 1 million. So put another bracket here. So we are calculating in square kilometer. That's the essence of dividing by 1 million. Then click OK. So it has been calculated. So you can now copy, right click, copy selected, open Excel sheet, and right click and paste. So you can find the total sum risk. So if you now come back to the arc map, so clear selection, close this, then click on file, click export map. So let's go to desktop, our flood risk, and call this flood risk map. Choose the format, let's choose PNG. The resolution, let's make it 400. Click save. It's done. So now let's go to that folder, which is, this is it. Then you can copy, open a new Microsoft Word and paste the map. So this is the map. Then the statistics, copy, right click, copy, then come back to that Microsoft Word and paste. So we have been able to address the questions by using building density and classify the flood risk into 4 risk level, and also we've been able to calculate even the area coverage of each of the zone, flood risk zone. So this is how to do flood risk assessment based on building density. Thank you for watching. Please subscribe.